We're going to talk about one more type of reaction. They're called neutralization reactions. Please remember as we go through this that you should be taking notes and writing down any questions that you have for me so that tomorrow when you come to class, I can answer them. All right, neutralization reactions. Neutralization reactions are really just a special type of double replacement. So it's really nothing new in terms of what's happening. It's just that we're going to use special kinds of reactants to get particular kinds of products. As you might have guessed by the name neutralization, a neutralization reaction happens when you have an acid reacting with a base. So your reactants in a neutralization reaction are always going to be an acid with a base, and you're always going to get a salt and water. Notice I don't mean as products. Notice that I didn't say salt, like table salt. I said a salt, any kind of salt. Remember that all ionic compounds are salts. So in a neutralization reaction, we've got two reactants, an acid and a base, and we'll get two products, salt and water. So what is an acid? An acid forms hydronium ions in water. This ion right here is called hydronium, and it's formed when you have something like hydrochloric acid, for example. When this hydrogen disassociates from this chlorine ion in water, it can kind of pop up over here to this water molecule and make a hydronium ion. So acids do that. They do this by donating a hydrogen ion in water. Bases, on the other hand, accept hydrogen ions. So anything that will take on a hydrogen ion is a base. Often, bases contain the hydroxide ion. So when you're looking at formulas, if it has a hydrogen ion in it, it's probably an acid. If it has an OH, hydroxide ion in it, it's probably a base. In general, acids have a pH of less than 7. So anything 6.5, pH of 2, a pH of 1, all of those would be acids. A pH of greater than 7 gives you a base. So 7.5, 8, pH of 10, all of those are bases. A pH of 7 is neutral. I'm running out of room here. So these neutralization reactions are trying to get it to neutral, right? That's the goal of a neutralization reaction. We're trying to get the pH to neutral of exactly 7. So pure water, for example, has a pH of 7. It's neutral. Acids tend to be sour, while bases are bitter. If you taste something that's bitter, that's usually basic. Something sour is usually acidic. Both of them are corrosive, meaning if you put a piece of metal in them, they will kind of eat away at that metal, or other materials too. It doesn't have to be just metal, but what you often think of. If you put phenolphthalein is just a chemical. Whoops, it has a long, kind of weird name, but it's just a chemical, and if you put it in an acid, it will stay clear. It will have no color at all. But if you put phenolphthalein in a base, it will be pink. That makes phenolphthalein an indicator. An indicator is just an indicator is just a chemical that you can put into an acid or a base, and it will tell you if it's an acid or if it's a base by changing color. Right? So indicators change color in the presence of an acid or a base. They're different colors when they're with acids than they are when they're with bases. Phenolphthalein is one indicator. Another indicator is litmus. Litmus tends to be red in acids, tends to be blue in bases. Okay, so here's kind of a comparison of acids and bases. Remember that the key thing about acids is that they form hydronium ions. The key thing about bases is that they accept hydrogen ions. The rule of thumb is that acids donate hydrogen ions, so they contain a hydrogen, and this is in water. And bases can donate or, well, not donate, usually have hydroxide ions in them. So this is sort of your rule of thumb. Hydrogens, acids, hydroxides, bases. There will be some bases that don't have the OH in them, but not very many. So let's look at neutralization reactions. Let's look at a couple examples. We've already said that a neutralization reaction happens when you have an acid plus a base. And then you end up with a salt and water. So let's look at an example. An example might be hydrogen and chlorine, right? Hydrochloric acid plus sodium hydroxide. Because hydrochloric acid has this H in front, I know it's my acid. Because sodium hydroxide has this OH, I know it's my base. Neutralization reactions, remember, are a double replacement reaction. So what's going to happen is that this, get a new color. This sodium is going to trade places with that hydrogen. So now this sodium is going to come over here and form NaCl, right? Sodium is going to bond with the chlorine instead of the hydrogen. And this hydrogen is going to come over here and bond with the OH. Right? HOH is just a different way to write H2O, right? Two H's, 1, 2, and an O. So there's my neutralization reaction. Let's look at another one. We could have hydrochloric acid again, bonding this time with calcium hydroxide. Still, I've got this hydrogen, which tells me acid. I've got this OH, which tells me base over here. So I've got a neutralization reaction. Double replacement means that this calcium is going to replace that hydrogen. Positive ion replacing positive ion. Right, they're going to switch places. So this calcium ion is going to come over here and it's going to take the place of that hydrogen. So now I'm going to have calcium chloride, and the hydrogen is going to come over here and take the place of the calcium. So I'm going to have HOH. To have a balanced equation, I'm going to need two of them. Right? So here's my salt, and here's my water. Let's look at the pH scale really quickly. The pH scale, we've got 7 here is neutral, right? Neutral is 7. Anything less than 7 is an acid. Anything greater than 7 is a base. Okay? The smaller the number, the more acidic. So bananas are 4.8 or so. Their pH is about 4.8. Apples are about 3.3. So apples are even more acidic than bananas. Okay? You can see some mostly foods here that we have, right? We've got bananas. Tomatoes are right about 4. Apples, a little bit more than 3, pH of 3. Vinegar has a pH of a little bit less than 3, so like 2.8-ish. Lemons are right at 2. And hydrochloric acid has a pH of almost 0, like 0.1. On the basic side, we have lots of things that are basic. We've got baking soda. Baking soda is a little bit more than 8, right? The pH is a little bit more than 8, so like 8.5. So it's not very basic, just slightly. Soap usually has a pH of about 10. Ammonia has a pH of about 11.5. Remember, this is what we use in like Windex and things like that. Drain cleaner has a pH of about 14. Blood and milk are 2 examples of things that are neutral. They have a pH of just about 7, real close to 7. So those 2 things are neutral. Okay, so here's what you should have in your notes. If you do not have these things in your notes, please go back and listen again. You should also have a couple of examples of neutralization reactions. If you didn't write down the examples, you might want to go back and watch again so you can get those examples and write them down.